All right, guys, so it's Thursday, April 9th. This is the last day of the school week because we all have tomorrow, Friday, off. So let's just go ahead and knock out these notes so that I can enjoy the weekend. All right, so today we're solving log equations still. The only difference is yesterday we were solving equations that had log on both sides. So you had to condense them and then cancel out the logs. Today's going to be solving equations where you have a log on one side only. So in this case, they do not cancel out, and it's not like the other problems that we were doing before where you take the log of both sides, so you can't just write in just one log on this side. I always see people try to do this. That's not the case. You can't do that here. So what you're supposed to do whenever you have only one logarithm is, first of all, you try to condense it if you can. This one doesn't have a number in front of the log, and there's already only one log, so there's nothing to condense there. So once you've condensed it, if you can, and there's only one log, you actually solve these by changing it to exponential, just like how we solved log in the past. So this is in the form, so we're going to do the conversion. This is in the form y equals log bx. Though it's a little bit flipped in this case, and we're going to convert it to be in the form x equals b to the y. So then it would look like, now notice how the 4x minus 2 is in parentheses. That means that the whole 4x minus 2 is what counts as x. So the 4x minus 2 is going to go right here. And then the base b is 4. And then the y is 3, so I'm going to write that down. So then once you do that, once you convert it from log to exponential, now you should be able to solve it. So I see a 4 to the third power, so I'm going to do that on the calculator. 4 to the third power, that's 64. And then once you change it like that, now it's just a simple two-step equation. Add 2 to both sides, and you get 4x is equal to 66, and divide by 4, so you get x is 66 over 4. Again, I'm lazy, but not too lazy that I don't simplify this fraction. So that's what it's going to look like when you're solving these logarithms. So if you have a logs only on one side, then you convert to exponential. So here's another example. So I have only one log, nothing to condense here. I don't have log on both sides to cancel, so then I need to convert. This is in the form y equals log bx, and then it's going to convert to be in the form x equals b to the y. So looking here, the x plus 6 is going to count as your x. So I'm going to write that down. And then b, well, b is going to be whatever is right here, but there's no number there for the base of the logarithm. So what are you supposed to assume? You're supposed to assume that it's a 10, common log. So then the base is 10, and then the y is 2. So you convert from log to exponential, and then you just simplify it from here. 10 squared is 100, and then subtract 6 on both sides, so you get x is 94. And there you go. That's what you do to solve these. All right, so that's what it looks like for a simple log equation. Convert from log form to exponential. These are going to be now where you use the properties in order to solve the log equations. So you notice how that it's always a simple version and then a complicated version where you use the properties. So on this first one, so my girlfriend's cat is currently playing with a paper ball, so that's what you hear in the background, if you can hear that. So the first one is 2 logarithms on one side of the equation. And before we can do anything, we need to condense that into a single logarithm. So this is addition. So how do you combine two logarithms when it's addition? You multiply. So then it would be log 2, and then you're going to have the x multiplying the 3. So 3 times x. So then let me just make that look a little bit nicer. So log 2 of 3x. Now, if you want to have parentheses, you can, or if you want to take them off, that's fine too. So then convert from, once you've condensed it down to one logarithm and you don't have logs on both sides, so then that means you need to convert. So y equals log bx converts to be x equals b to the y. So then it will look like 3x is equal to 2 to the third power. So simplify, 3x is equal to 2 to the third power is 8, and then divide both sides by 3, so x is 8/3. So that's what it looks like when you use a property and then convert to solve. So next example is same thing. I see multiple logarithms, always have to condense. So I see that this one is subtraction this time, so that means when I'm going to combine them, I'm going to combine using division. So it's going to be log 6, and then I'm going to have the 8x minus 8 being divided by 2. And I'll bring the 2 down. Now, this part, make sure you're careful. These are the 8x and the 8 are both going to be divided by the 2. So then it's going to look like log 6 of 4x minus 4. This is a case where I would recommend that you leave the parentheses. That way the 4x and the minus 4 stay together. So after you condense to one logarithm, simplify if you can. And then now it's a problem like the other ones. Convert from log to exponential. X equals b to the y. So then what would this look like? 4x minus 4. And the base is 6 and the y is 2. So simplify, you get 4x minus 4 is equal to 36. Add 4 to both sides, so you get 4x is equal to 40. And then divide both sides by 4 and you get x is 10. So there you go. So the first example, solving by converting from log to exponential. This one you had to condense first and then convert from log to exponential to solve. All right, so here's your homework. So you have these 4 questions, but I also threw in a challenge question. It's really not that difficult if you remember one of the specific properties. Like always, make sure that you turn the homework in on time. Ask any questions if you don't understand, and make sure you check your work for any previous